So welcome to 10.2. Now I'm going to give you some graphs and you're going to write the linear functions. Okay. All right, so let's remind ourselves how to use y equals mx plus b, right? So the y-intercept here is 0, 4. The slope, right? You're going to find your good intersections, find your slope. So you need both the y-intercept and the slope of both of these. Do that before I do, please. So this y-intercept is 0, 4. This y-intercept is 0, 8. Right, now notice the scale here. We're going to have this today. You have to look at the scale. The scale here is the normal 1, so that's good. All right, so the rise is 1, the run is 3. Now these numbers are not always going to be 1s today, so we got to check that. But this is going up by 1. So the slope here is 1/3. Here are the good intersections here. We're going down 2 and over 1, so the slope is -2. So the equation, right, we're going to use y equals mx plus b. So this is y equals 1/3 x plus 4 over here. And over here, this is y equals -2x plus 8 was the y-intercept. Okay, so you're going to be doing the same thing, just real-world versions of that. All right, so let's look at this. This is a graph of the height of a tree. And so we're going to use letters instead of x and y. This is y for years, not y for y equals mx plus b. And this will say we'll use height here. You could use f for it. But see, look at the y-intercept. It's right there. Right? What's the y-intercept? Right? These are going up by 5, so it's 0, 15. Now, the tricky part of today, that is not a slope of 1/2. Not. Why is that not a slope of 1/2? Well, these are going by 1s, so one box, each box is worth a year, so the run here is 2. But the rise here is not 1. Why is it not 1? It's one box. But what's a box worth? A box is worth 5. All right, and we're going to go over that again. The slope of this is 5/2, also known as 2.5, because a box is where you're going to need this number. You want to know this number every single time because it's what a box going up is worth. All right, so the slope here is 5/2. Okay, so let's do our first one. We'll start with the easy part, find the y-intercept. So the y-intercept is right there. Now, what's this number? Halfway to 24, 12. So we're doing the 12 times table. 12, 24, 36. So our y-intercept is 0, 36. Now, they're all good intersections, right? That normally means a slope of 1. Well, let's look at the run. The run along this bottom here, right? Whoops, oh my goodness, I had a brain freeze there. 5, 7, 9, all right. Each worth 1. So a box is worth 1, so the run is 1. But the rise is not 1 because one box going up is worth 12. So the slope here is 12. All right, so what would be the equation? And let's use y and x this time. So it'll be y equals 12x plus 36. That's what will make this graph. The y-intercept there, the slope there. This will be the #1 mistake on the test. People counting the boxes and forgetting that one box is not worth 1. I'm going to be nice and leave this down here as one box equaling 1, I believe, on every single one. Okay? It's this one that's going to keep changing, and it's going to be different every time. Okay, so let's practice here. So one box is worth 1 here, so we're good. But going up, one box seems to be worth 6 this time, right? All right, so the y-intercept is 0, 12. Now find your slope. Please find the slope before I tell you. All right, so it's the run is 3 because it's 3 boxes and each box is worth 1. But what is this rise? This rise in this case is worth 6. So the slope is 6 over 3, 2. All right. Right, you could see on the test people saying the slope was 1/3 because if this was 1s, it would be, but it's not. So the equation here is y equals 2x plus 12. Let's do this again. All right, so this is where I might start even before I look. What's a box worth? A box is worth 25. Okay, so a box is worth 25. A box is worth 1. Mr. Ben didn't lie here. Okay, the y-intercept is right there, 0.75. The slope here, the run is 1, but the rise is not 3. What is the rise? What's 3 boxes worth? 3 boxes is worth 75. So the equation here is y equals, and I should have written y and x on these, by the way. Y equals 75x. Whoops, nope, the slope, yeah, the slope is 75. Oh, and the y-intercept is 75. Y equals 75x plus 75. Okay, so now we're going to do the real world. So instead of y and x, we're going to use p and h. So where y would go, right, you're going to put a p. Where x would go, you're going to put an h. Okay, so let's start. What's the y-intercept? Right, in this one, the y-intercept is 0, 0. Okay, now find the slope. Be careful. All right, so every intersection is good. It looks like a slope of 1. Well, the run is 1, but what's the rise? It's not 1. Ah, 1 box is worth 12. So the slope is 12. All right, now, right, we're using y equals mx plus b, but instead of x, we're using h. Instead of y, we're using p, right? And so it's going to be p equals 12h plus 0. P equals 12h. All right, let's see if we understand that. In 1 hour, he makes $12. In 2 hours, he makes 24. In 3 hours, he makes 36, right? Yeah, in the last lesson, you were filling in t-tables like this, right? He works no hours, he makes 12. Oops, he makes 0. Works 1 hour, he makes 12, right? 1 hour, he makes 12. 2 hours, he makes 24. 3 hours, right? What equation made that table? The pay is 12 times the number of hours. In fact, I think you graphed this exact one in the last lesson. Okay, so we're going to be renting a boat. So let's first of all find our y-intercept. So our y-intercept, well, here we're going up by 12s. So 12, 20, so the y-intercept is 0.36. I didn't say dollars here, but let's assume it's dollars. And so we're going to have cost. Wherever y would be, we're going to use c for cost. Wherever x would be, we're going to use h for hours. Now the slope. So the slope, right, there are good intersections. Once again, it's 1 hour for the run, but what's the rise? Well, it looks like 2, but what's 2 boxes worth? 2 boxes is worth 24. What does that mean? Yeah, that means it's $24 per hour to rent this boat. That's what that's saying. The rate is your slope. So we're going to use c where y would be, right? We're using y equals mx plus b. We're replacing that with c. The slope is 24. It goes right there. Replacing x with hours. Now we have a y-intercept of 36. That's the equation that makes that line, right? If we put it in a t-table, you work 0 hour, or you rent this boat for 0 hours, you have to pay 36 bucks. All right, why? Deposit. Right, 1 hour, then 1 hour, it's 24 times 1 plus 36, which is right there, which is 60, I believe, right? And 2 hours, you don't have to do this table. I'm just showing you how this works. In 2 hours, right, now we're at 84, and so on. This equation makes this line, makes that table. All right, now, in high school, instead of y, they write f of x, okay? And it means the function as a function in terms of x, okay? It's just a way of writing y, all right? And so we're going to use this right now. It's not that much different than what you're doing. So let's do this exact same thing you've been doing. All right, so each box is worth 6. So our y-intercept is 30. Okay, now we need our slope. There's our good intersections. And so our run is still Run is 2 now, not 1. There's 2 boxes, but they're each worth 1. Now, the rise is not 1, right? A box is worth 6. So the slope is 6 over 2, or 3. Okay, so now we're going to replace F with C, okay? And we're going to replace X with P, okay? And what you write is C of P equals 3P, there's our slope, plus 30. So what's the difference from the last screen, right? The last screen we wrote C equals 3P plus 30. What this says is the cost is a function of the number of pounds you bought. And you read that as C of P. So if you're asked for function notation, that's really the part you're adding. Instead of just saying C equals 3P plus 30, it's C of P equals 3P plus 30. Those are the same thing, though. They're not mathematically different. And this is not multiplication. This is saying that the cost is a function, is related to the number of pounds you bought. Okay. All right, so it says using proper notation. So we're going to use function notation here, but it's the same thing. Let's find our y-intercept and our slope. So each box is worth 1 everywhere. That makes life easy. So 17, 18, 19. So our y-intercept is 0, 19. Notice I always write the y-intercept as a point, not as a number. Okay, now the slope. Okay, now the slope looks like it's -2, right? We're going down 2 and over 1. And because each box is worth 1, it is -2. Okay. So now we're going to use, it says use H for height and T for hours. Now why did I change this? You can do H of H, but it's awkward, right? So often that is corrected by making hours time, T for time. So we're going to do H of T. Now we need the slope is -2t plus the y-intercept. Okay, slope goes there every time, right? There's b of the y-intercept. Instead of saying, so this one with this, the other one in these parentheses, h of t. Height is a function of time. The more time goes by, the lower the water gets. The height is a function of the time. It starts at 19. I didn't say, does it say inches? Let's say it's 19 inches, and it's going down 2 inches per hour. Okay, we're practicing. Find our y-intercept. So each box is worth 25 here, so our y-intercept is 0.75. Find our slope. So looks like that. Run is 1. The rise is not 2. 2 boxes is worth 50. So the slope is 50. So what does that mean? The car is going 50 miles per hour. That's what it means. It says to use M and H. So you're going to do M of H equals 50H plus 75. All right, we have a flower growing. Use H for height, D for days. Okay. So our y-intercept is what? Ooh, each one of these is worth 2. Is that right? Yeah, so each one is worth 2. Be careful of that. So the y-intercept is 0.12. The slope, yep, each one is worth 1 along here as usual. So every intersection is good. So it looks like a slope of 1, but it's not, right? It's a slope of 2 because each box is worth 2. We're doing H of D. The height is a function of the days this flower has been growing. Equals 2D plus 12. Please get in the habit of using the letters that are provided. Do not use Y and X for this. Okay, so final question here. And each box is worth 1 there. Oh, and each box is worth 1 there, so that's nice and easy. So the y-intercept is 0.13. The slope, let's look at this. Okay, let's be careful here. Okay, so the run here is 2 boxes. Each box is worth 1 along the run as always. Now, we're going down 1 box, and each box is worth 1, right? So the slope is -1/2. Yeah, and let's use H for height. I should have written that there. So H equal, oh, and we're going to use function notation. It doesn't say you had to, all right? So you could write it either way. And let me write it both ways so you see. All right? It's not much different. Right? Negative 1/2 t equals negative 1/2 t plus 13 plus 13. Yeah, I get students who put parentheses there. No, that's not a thing. Okay? The parentheses go, you're just adding, saying that the height is a function of time. This is called function notation. And in high school, that's the way you will write these. Typically, in middle school, you write them that way. I'm just trying to get you ready. Okay? There's not much difference. Good luck with the homework.